All right, quick, add all the whole numbers from 1 to 100. There's a pretty famous story about this mathematician, Carl Friedrich Gauss, when he was in elementary school, primary school. Either he got in trouble or this was just a math problem from his teacher, but she said, I want you to add up all the whole numbers from 1 to 100. She expected this to take a really long time, like think about being on a slate board, but just within seconds, Carl Friedrich Gauss had solved this problem. So this strategy is going to be how he did that. So basically the idea here, when Carl Friedrich Gauss was noticing that you're adding all these numbers from 1 to 100, all these whole numbers, he noticed that these numbers could be thought of as being in pairs. If you added up 1 and 100, you got 101. If you added 2 and 99, you also got 101. If you added 3 and 98, you also got 101. So what's being noticed here is that we have many pairs, and in this case, since there's 100 numbers, half of that is the number of pairs. So we have 50 pairs, each with a sum of 101. So a very nice shortcut to solve this problem is just to do 50 times 101 and arrive at an answer of 5050. All right, so this technique that Carl Friedrich Gauss used works for every arithmetic sequence. So if we're going to find the sum of the terms of an arithmetic sequence, we can add the first term and the last term and multiply the sum by the number of pairs. That's the number of terms divided by 2. So let's put together what we learned in the last little mini lesson and this one to find the sum of the first 20 terms in this sequence, 4, 10, 16, 22, etc. So the first thing we're going to look for is what's the common difference. So it looks like we're adding 6 each time. So notice, if we solve this like we've done before, we're going to start with the 4, and then we're going to add 6 a total of 19 times to get to that 20th term. When I do 6 times 19 and add the 4, we get 118. This means that the first term is 4 and the last term is 118. So if we add 4 and 118, we're going to get 122. That represents the sum of each pair of numbers in this sequence. Because there are 20 terms, there are 10 pairs. So I can solve this problem by doing 10 times 122 and get that the sum of these 20 terms is going to be 1,220.